Welcome, everyone. We appreciate you joining us today. My name is Brett Peterson. I'm the Director of Sales and Operations for North, Central, and South America. Today, we'll be discussing some of the new exciting upgrades and features of our newest release of Isograph's Reliability Workbench 15.0. The Reliability Workbench, as many of you might already know, is comprised of a variety of software modules that can be purchased a la carte, and we'll be touching on the key upgrades in these modules today. As many of you know, Isograph has been developing software for engineers for over 35 years, and the vast majority of our software updates are requests directly from our users. Now, today we have the pleasure of hearing from Dr. David Wiseman, our lead technical support and corporate trainer that's based out of the UK. We also have our veteran lead technical support and corporate trainer of over 17 years with us, Mr. Joe Beland, and they'll be doing a co-presentation today to cover the information. Just before we get started, just a couple housekeeping items. Due to the large attendance of today, which we really appreciate, if anyone has questions, please pose these questions in the question box on the bottom right-hand corner there. And periodically, Dave and Joe will stop and answer those questions that pertain to the group. If anyone has any one-off questions, that need to get answered, feel free to email support@isograph.com or sales@isograph.com, and we'll make sure that we get a response back to you quickly. Once again, really appreciate everyone's attendance, and without further ado, let's turn the time over to Dave and Joe. Let me just share the screen with them quickly. Make sure that they can see this. Joe, would you like the screen first, or would you like David to have that?
How would we let David go first, if that's okay with you, David? I think he had the more interesting stuff to show.
Yeah, no problem at all.
Sounds
So if you will bear with me for a moment, I'm going to bring up. So let me see. So yeah, Brett, Joe, can you let me know, can you see my screen now?
Yes, I can.
Excellent. Okay, so good morning, everybody. My name is David Wiseman. As Brett was saying in the introduction, I'm sort of technical support and customer training for Isograph. I'm based in the UK. And today I'm going to be taking you through some of the new features and facilities that have been added to the FMECA, the FMECA module of Reliability Workbench for version 15. So I've kind of got a loose agenda I'm going to work through. I'm going to start with the kind of big new features that have gone in. There are a few of those, after which I'll work my way through some enhancements to existing features. And at the end, I'll show you a couple of ease of use improvements that we've added to the software. So to begin with, I'd like to talk about a new feature we've added, which will allow you to allocate a SIL, safety integrity level, to a failure mode based on the standard IEC 51508. So this feature you will find in FMECA if you create a new failure mode. I've got a little FMECA or FMEA set up here in the software just to demonstrate. FMECA users will probably know in the project options for the FMECA module, you can, of course, select to do a process FMEA or a design FMEA, in which case you would be dealing with rankings rather than failure rates, risk and criticality. So I've selected the process FMEA in this example. So when I create a failure mode, I have the option to rank that failure mode by its occurrence and its detection, how often it will occur and how easy it is to detect. And any high level effect, any end effect that this failure mode is associated with, its severity ranking will be inherited by that failure mode. So you can see here, this failure mode has a hazardous ranking, which it's inheriting from its high level effect. But of course, that's all stuff that we already know about that's in the software already. What we've added is this verification tab. So on the verification tab, the program will look at the tolerable hazard rate that is associated with the severity ranking. So hazardous ranking 9 has a verification tolerable hazard rate of 10 to the minus 9. And then the program will allocate the appropriate SIL for that hazard rate. Now, those hazard rates are set in the project options. So again, I'll close the dialog and show you where that is. On the rankings tab, again, if you're familiar with Formica and FMEA in our software, you'll probably know where to find that. Here you can see, along with the descriptions of the severity rankings, you can now specify a tolerable accident rate. That's what the program is using to then allocate the appropriate SIL. There are the SIL rankings. And again, this is customizable, so you can modify the tolerable accident rate associated with each SIL. We've just got a bunch of default values set up here. So the program has seen that my accident rate is 10 to the minus 9, so it's associated with that SIL ranking 4. If I were to choose, say, a lower ranking, so I'm going to drop that maybe to moderate, and I will run an analysis of my FMEA. Go to my verification tab, you can see now that's allocated SIL 1 based on the lower hazard rate. So again, from that standard, it is possible to adjust your tolerable hazard rate using mitigation factors. Now, the mitigation factors you can see here at the top, you can activate these for your failure mode. And these are F, P, and W. I can set some values for these. They have to be between 0 and 1. And you can see even as I'm doing that, the program is adjusting the hazard rate and adjusting the SIL accordingly. This is actually a little tweak that's been made to the software that now when you make a change in the dialog, some of these results will update automatically as you're doing it rather than having to run the analysis again. That's just a little footnote. But as you can see, you can use these FPW factors to adjust the tolerable hazard rate and then adjust the SIL allocation accordingly. So that's a little bit about the SIL allocation that's now possible through the FMEA. Now there is another little feature that's been added on the verification tab as well. What you can do now, and I'll show you this with another failure mode, I'll just get rid of that. I have another failure mode set up here, and on my verification tab, I told the program to use the verified hazard rate for results occurrence rankings. Now, what this means is I can now attach this failure mode to another analysis. In my example, I've attached that to a fault tree gate in the fault tree module of the software TP1. And the program will pull through the failure frequency. So you can see that here. So it's using the failure frequency of that fault tree gate as the verified hazard rate. And what it will do is it will take that hazard rate, again, compare it to the hazard rates associated with the occurrence rankings in your project options, and it will automatically assign a results occurrence ranking. So for your action results, if you turn on this option, you can no longer manually set the occurrence ranking. That will be set automatically by the software based on the frequency coming through from the associated analysis, in this case, a fault tree gate. It could probably be like a prediction analysis, or it could be an RBD. But in this case, I've chosen to use the fault tree to demonstrate that. So that's an overview of the IEC 51508 facilities that have been added to the software. Again, that mostly affects working with FMEA and working with failure modes in the software. So elsewhere, now we're getting on to things that are maybe more appropriate to anybody in the audience who is working in the automotive sector. We've got some significant enhancements in the area of the AI, AG, and VDA FMEA handbook. So this is the 2019 edition of the FMEA handbook. And what we've done is added the action priority rankings to the analysis. So I'm going to open a different example project, again, only a very simple one. So here, again, I have a failure mode, and this is in one of the FMEA standards, process or design FMEA, doesn't matter which one you choose. And again, with it being a FMEA, I can choose rankings, severity, occurrence, detection. Now, obviously, as before, when you run the analysis, the program is going to generate the risk priority numbers. That's a given, that's something that was already there before. But now, as you can see down here in the grid, the program can also generate the action priority ranking as well, low, medium, or high, based on the rankings that you've chosen for your failure mode. So I might try and drop these a bit and see if I can get a different result. So you can see immediately that changes to low based on the selections I've made. So I'm going to try and pop this up a little bit, see if it changes. It goes back up to high. So you will get action priority results for your rankings. For your action results rankings, there are also results action priority rankings as well. So you'll get the action priority and the results action priority. So both of those rankings are generated by the software. You can display them in the grid, pull them out in reports as part of your FMEA. Now, towards the back of the handbook, there is also an alternative methodology similar to the action priority analysis, the MSR option. So if I go to the General tab, so you can see again, I've got my FMEA selected. At the bottom now, there is an option for the MSR preference. So if I choose that, the program will now assign the action priority based on a different set of criteria, which again is set out in an additional couple of tables towards the back of the FMEA handbook. Another little sort of visual change you'll probably notice when you make that selection is that now, when you are setting up monitoring ranking, detection ranking for your failure mode, it will be labeled as monitoring instead of detection. So you have that MSR option for generating your action priority rankings as well. So while I'm in this project, again, talking, I guess, well, to the automotive crowd, but also I think more broadly, maybe to IEC 61508 and 61511 crowds as well. An additional object has been added to your FMEA and FMICA and FMEDA analysis, and that is the requirements object. Now, previously, if you wanted to specify, say, a functional safety requirement against like a failure mode in your FMEA or your FMEDA, you'd have to do that using one of our text boxes. Now, you can actually create a distinct object called a requirement that can be attached to a failure mode. So up here, where previously you would have found your apportionments and your phrases, there is now a requirements button. So I can add a requirement, and let's see, let's add a requirement. I'll just give that a bit of text. There is also a long text description as well. Obviously, the short description might not give you enough characters to fully describe your requirement. Long descriptions appear now for a couple of objects throughout the modules of the software. Those long descriptions have also had a little tweak made to them as well. I think they can now support something like 20,000 characters, which means that you can now describe in some detail things like requirements, safety mechanisms, and so on. But I will click OK to create that requirement. And of course, you can have a whole list of requirements associated with your project. I will close that. And I will go to my failure mode. And you'll see now there is a requirements tab. So I can go to requirements and say, OK, for this failure mode, I have a particular requirement in order to prevent or mitigate this problem. So I can search for that, grab my requirement, okay, and there it is. And naturally, there could be a whole list of requirements here. I'm not limited to just one. I can have as many requirements in this list as I need. So that's the requirements. They don't affect the quantitative analysis in any way, but they are purely informative, and naturally they can be pulled out as part of your reports and so on. Now this ties back nicely to some of the library functionality I'll be showing you a bit later as well. But for now, just say requirements have been added as an object, which you can now attach discretely to your failure modes as, again, discrete objects. So I will click cancel. So from here, I'd kind of like to move from sort of new things that have been added that weren't there before to improvements that have been made to existing features. So for that, I'm going to open another example project. Again, these are some nice options here for the automotive audience. So I'm going to go to our ISO 26262 example project. And again, flip back to the Formica module. So anybody who's been using the most recent versions of our software will know that a little bit like we've added requirements to this version, in very recent versions, we've added these safety mechanisms as objects that you can use in your Formica and Formia. So those are here under S, where you can add safety mechanisms with which you can associate diagnostic coverages for single point and multiple point faults. Those can then be associated with failure modes in your hierarchy through the ISO 26262 tab of your failure mode properties. What the first thing we've done, and I feel like it's quite a big update as well, is that now you can specify a different safety mechanism for the single point and latent faults of a single failure mode. So if I go into the project options and to general, you can see here there is now an option to split safety mechanisms. So if I turn that on, and I go and find one of my failure modes, you'll see if we go to the ISO tab, there is now a separate single point failure safety mechanism and latent failure safety mechanism. So I can create a new one, completely separate SM2, and just give that entirely different set of diagnostic coverages. So now I've got SM1 for single point, SM2 for latent faults. So of course, in this case, it will take the single point diagnostic coverage from SM1 and then the perceived and detected diagnostic coverages from SM2. And another nice feature that we have also is that you now can override the defaults. So you might say, well, okay, I'm using safety mechanism 2, and the default coverages are 50 and 60%. But maybe I've applied safety mechanism 2 to a particular fault where maybe the diagnostic coverages aren't quite the same as they would be normally. So I can click the checkbox and say, okay, I am using safety mechanism 2, but I want to override the diagnostic coverages in this case. So now you can override diagnostic coverages even when you are using a safety mechanism. So now some, I guess, more general improvements. So if we go up a level and take a look at our effects. So we were looking at the bottom level failure modes a moment ago. Now we're looking at intermediate effects at this sort of overcharge protection level. I can open that up and go to ISO 26262. Now you can see here that all this is grayed out. If you've run an analysis using our ISO Formica stuff before, you'll know that these coverages and so on are calculated automatically by the software based on all the coverages and failure rates and so on coming from the lower levels. You can, if you wish, go to intermediate level and enable these options. So now, instead of just inheriting what's coming from the lower levels, if it's appropriate, you can override that with safety mechanism and other percentages at the intermediate levels as well. So you can stick safety mechanisms and so on in the middle of your failure mode and effect hierarchy, as well as at the bottom. And this is, there is a similar feature now that's been added for FMEA as well. So if you're doing a FMEA with occurrence and detection and severity rankings, you now have the option to enable those rankings at intermediate levels of the hierarchy as well. So again, you can override what's coming from the top or bottom levels and set rankings in the middle of the hierarchy also. And then one other little thing that was been requested by a few customers, up to now, you've been able to set failure modes at the bottom of your hierarchy and then specify what are the immediate next level effects and the higher level effects and so on in that hierarchical structure that we're all familiar with. Several customers though had asked to be able to specify what is the effect of the failure mode at that same component level. So I guess, hand waving example, a particular electronic component undergoes a certain failure mode. What is the effect I see at that component level, not just at the next level up? So now, if we take a look at the failure modes at the bottom of the hierarchy, go to the effects tab, you see all the same stuff that was there as before, where you can add effects at the next or higher levels, but now there is also a local effects box as well. So you can specify what are the effects that you see at this level of the hierarchy as a result of the short failure mode. So before I sort of wrap up on FMEA and the new features there are a couple of little ease of use things that have been added to the software. So I guess a lot of you would probably have seen or used the library facility before. This is the facility that allows you to attach one project to another and pull information from that project into a new project or an existing project to kind of speed up that building process. What you may not have been aware of, because say it's not part of the normal drag and drop interface, is that you can also transfer the contents of things like your apportionment library and your phrase library. So what we've done now is, if you're in the library view, you'll see there is a library menu. We can click on that, and if you look here, you've got options, of course, to transfer your apportionment library between project and library or library and project. But now there are options here to move the severity rankings. So if you've got a list of severity rankings for your FMEA or in another FMEA project, you can easily transfer that from the library into the project. The same goes for the requirements. So these new requirement objects can also be transferred in the same way. But as you can see, all these 5 buttons, apportionments, phrases, severity, safety mechanisms, and requirements, all have an option. So all of those libraries can be pulled from one project into another very easily through that library menu. And again, I'll just show you here, because if you're looking at the normal failure mode view, that library menu is hidden. So if you're wondering where it is when you're using the software, if you flick to the library view, that's when that library menu will pop up. So one last thing that's been added, again, it's just a little ease of use thing, is that if I'm, let's say, working with a failure mode, and I've put in, say, just put a little bit of extra text, I put in a description of my failure mode, and I decide that I want to actually use that description again in the future, I can highlight that, and there is now a save phrase button at the bottom where I can click save phrase, and I have the option to save that as a failure mode description in my library, so in the phrase library. And it's a pretty clever feature because it will actually just act on whichever bit of the text you highlight. So if you just highlight where it says short, you select that, click save phrase, and now it's just grabbed that part of the text. So this is a feature that will let you, just move text that you've written into a field into your phrase library, whereas before, what you'd probably have had to do is sort of copy it to the clipboard, then go into the phrase library, create a phrase, paste it, and so on. This is just a nice quick shortcut for creating phrases based on text you've just put in to a dialogue. And that's it. That's an overview of the new features, new enhancements and improvements that have been put into the Formica module. And they cover a variety of things from Formica and Formida through to PFMEA and DFMEA. So Brett, I'm not sure if you want to open things up for questions now or just keep moving and let people type questions as we go. But that's it for Formica, and I'm happy now to hand over to Joe if he's ready.
Perfect. Thanks so much, David. Yeah, as questions come in, I'll pose those. And yeah, let me turn the time over to Joe as the presenter to continue moving on.
Sure, thanks, Brett. Just give me a second to share my monitor. Here we go. Let me know when you've caught up and you can see my screen.
Yep, I've got that, Joe.
Sure, okay. Okay, well, I was going to take over from David, and he focused mainly on the Formica updates. And I was going to show updates from a few different modules. And I was going to start in the reliability prediction module. So if you have the release notes document, you'll see there's a number of different updates that we've made to several of the different modules within Reliability Workbench. So I'll start with prediction module. And a few of these updates are ones that I specifically worked on or worked with users and getting into this software. So I wanted to highlight a couple of those that that users requested specifically for me that we got into the software. The first one has to do with easing the ability to import BOMs into the reliability prediction module. Now, of course, BOM imports has been a part of the software for quite a while. Whenever you're doing any sort of decent sized prediction, you're probably not going to want to have to create the whole thing by hand in the software. Of course, you can do that, but it becomes quite tedious after a while. We want to speed that process up as much as possible through the imports. And of course, we've for a very long time had the ability to import from Microsoft Excel. So I have here a very simple BOM that I might have. I might have downloaded this from some other source. I might have just collected information on the parts that I have in my system. So this is I kept it simple by intentionally to make it as easy as possible for this example. So I have a very simple BOM. It's a power supply and all the electronic components that make up that power supply. And now I want to do a reliability prediction on this. So I want to import this rather than having to enter all these parameters by hand. So one thing I've done, and of course all of this is so far has been possible through the tool. So I've created a new sheet and sort of expanded upon that BOM. Firstly, I added a unique ID field for every entry. I added a parent field to indicate the hierarchy that all of these components here, so all these components here are children of block 1, which is this row here. So that will do the hierarchy. I also want Reliability Workbench to automatically recognize the kinds of components each one of these is. So these should be recognized as capacitors, a transformer, a diode, and a couple of resistors. So I've added a category keyword that indicates the category of the components. So I'm going to be importing them into the MIL 217 standard, and I've indicated the category. That category keyword, by the way, can be seen in the software. If I jump into Reliability Workbench, whenever I add a component into the prediction, you'll see its little keyword right next to the category dropdown. When I choose a specific category, you see that keyword there. Okay, and then finally, there's a lot more to import or to set for each component when you're doing a parts stress analysis. So when we go back to adding, say, a new capacitor, there's also all these parameters that you might want to set as well. So if I look back at my BOM, at the description of my components, some of this can be inferred. So for the capacitors, the style, so it's a polyester or a ceramic chip or an electrolytic aluminum or solid tantalum capacitors, and also their capacitance, 33 picofarads, 4,700 microfarads. All that information is available in that description. And so that can also be imported using what's called the parameter values keyword field. So in Reliability Workbench, all these other parameters here are stored in this parameter values keyword field. And if I add that capacitor, you can see it's sort of a coded phrase to define all those extra parameters. So now all of this has been possible in the software for quite some time, that I can import all this data. Now, the thing is, a lot of that data, so I'm only really inferring a couple things from each of those components: the style of the capacitor and its capacitance, the style of the resistor, etc. Everything else that I don't set, that I haven't set in my BOM for this param values key field, will inherit a default value. Now, that default value can be set in the software. So if I'm importing or creating within the software a new component, if I can set those default values for everything else via the special functions menu. So I first choose the standard I'm working on and the component type that I want to set, and then I can come to the special functions component block defaults menu, and it will give me the it looks like the parameters tab of the the block properties dialog, but these will be the default values. So if, well, again, for a capacitor that generally have 2 pins, but things like the rated voltage, maybe I'm not working in a 2-volt system, or the operating voltage is set at 0.8 volts. Maybe that's not this system. Maybe it's going to be 0.5 volts for this particular system. And also maybe the type of the capacitor can also be set by default. The temperature, the environment, all those values can be set by default. Right? And now when I've set those values and I add a new capacitor, you'll see the default operating voltage was inherited from those defaults. So we've had the ability to set this for a while through the software, but when you're importing a bill of materials, it can be a little cumbersome to first come into the software, go through each component type that you want to set the component block defaults, and then do your BOM imports. More likely, when I'm importing that BOM, there's going to be a lot of these values. For instance, my environment and my temperature are probably going to be somewhat global. Also, the operating voltage, maybe even the rated voltage, all of that will be probably somewhat global for all of my capacitors within the system. So rather than either adding that parameter value to here, to this field, and setting temp equals 25 to every single one here, I can now import these defaults. So I've created a new tab on my spreadsheet, the PD user defaults tab. And for each component type, I can set each one of those parameter values to a default value. So rather than having to specify every single one of my capacitors is rated at 2 volts, or has a voltage stress ratio of 80%, or is an airborne inhabited cargo environment, rather than having to specify it one by one for every single entry in my BOM, and also rather than having to first go into Reliability Workbench and set it, then come back to my BOM and import, I can set those default values through the bill of materials itself. Now, if you're wondering what these keywords represent, again, you can see them in the software tool. If I come back here, this parameter values field, you can see those code words. And also we have we've had this for a while, a guide that's available upon request, a prediction keywords text guide that gives all the codes for all the different parameters for all the different component types. So now when I've set those default values, I can, let me just create a new project. I'm going to start by importing, here I'll do it via the clipboard. I can of course do it by importing the Excel file. Actually, that might be even easier. Let me just import the Excel file. I'll import the Excel file, find that file, it's my bill of materials. Oh, it's already open. I need to close it in Excel, because Excel has a lock on the file and doesn't allow other things to read it while it's open in Excel. So let me try that one more time. So I link to the file. I can do the import. So I'm going to first import my user defaults, PD user defaults, and do the auto column match and import. And now we'll see for that capacitor, the component block defaults have been set how I define them in my file. The voltage stress mode is user specified, a rated voltage of 2, and an 80% voltage stress, a default environment of airborne inhabited cargo, and a default ambient temperature of 25. Now when I import the bill of materials, so let me go one more time through that import, find my Excel file, column names in first row, always. Now I'm going to import my PD blocks table, that's the prediction blocks themselves, And when I do that import, all my objects get assigned those default values. So if I look at this capacitors, they're assigned the default rated voltage, environment, temperature, and voltage stress ratio. So again, this is just another way of speeding up your prediction. Rather than having to enter all this by hand in the project, you can set it up, predefine it in the bill of materials. And when you do that import, all those defaults can be set as well. And what's more is, of course, I can save those user defaults. And even if I'm not using a bill of materials, I might save those user defaults to an Excel spreadsheet. And whenever I start a new project, I can predefine essentially my component block defaults for all my component types using an Excel spreadsheet, and then I could begin every project by importing those user defaults and then starting to work on my project and have the defaults set the way I want them to. I can use this to coordinate if I have multiple users and I want everybody to be using the same defaults for the blocks. I can use those default values. Okay. And of course, I've been working in the MIL 217 module, but of course these work for all modules. So each module will have its own keywords and various codes for the different component types. So I've been working in MIL 217. It would also work for, say, the SN29500, and that has its own keywords. So if I add a SN29500 block, and then it will have its own capacitors and their own default values. Again, remember, every prediction standard will be slightly different from the others and have different values that you'd specify. So I can set different user defaults for the different standards as well. Speaking of the SN29500 standard, we've made a new update in the software, in the prediction module, for the Siemens SN29500 reliability prediction. You'll actually notice there's a new code after it, IEC 61709. So it's now no longer simply the Siemens SN29500 module. If you have a license for SN29500, you've also gained a license for the IEC 61709. So let me explain a little bit about what's going on here. The IEC TR62380 standard has been in the software for quite some time. However, from time to time, users will come to us and point out that technically that standard's been deprecated or updated. There's a newer IEC standard that's supposed to replace it called IEC 61709. Now, of course, when 61709 came out, we looked into it and adding it to the software. However, we noticed one shortcoming that the standard seemed to have that didn't really work well for our users. Whereas most prediction standards supply not only the failure models to calculate a failure rate based off the part stress analysis, how it's being used, they also supply a reference failure rate. So as an example of that, if we look at, say, MIL Handbook 217, say the equation to calculate the failure rate for a capacitor is based off of a reference failure rate, that's this lambda b, and then the parts or the component stress modifiers, the pi factors as they're called. Now, this is the way most reliability prediction standards work. The exact equation will vary from standard to standard, but it will be based on this general format. Now, when IEC 61709 was released, they included this part, the pi factor part, but they did not include the reference failure rates. Now, we talked to a lot of our users, and a lot of them agree that this wouldn't be particularly useful. One of the main things we want from reliability prediction when we're doing that is we need the base failure rates, the reference failure rates to be supplied. Generally, we're using prediction when we don't have any information about the failure rates of our components. So we want both the reference failure rate and the model on top of that will adjust the failure rate based on the usage, the part stress analysis. Since 61709 didn't supply that, many of our users didn't find it particularly useful and would stick with the IEC TR62380 standard. Now, one standard that did use the 61709 models, but also provide reference failure rates was the Siemens SN29500 standard. So for a while, we've just suggested users to use the Siemens SN29500 if they want to use the newer up-to-date 61709 models. So what we've done in the latest version, so we've had that SN29500 standard in the software for quite some time, but in the latest one, we've added some features specific to also more closely tie in the 61709. Firstly, our failure rate source, we've added this to all the component models when you're using the SN29500, you can choose your failure rate source as either the SN29500, in which case it will use the reference failure rate from the Siemens standard, or you can do it 61709 style and provide a user-defined reference failure rate. You provide your own base reference failure rate as you would do if you were using a straight 61709 style analysis. Additionally, there are some very minor differences between 61709 and SN29500 calculations, particularly with regards to the pi-t, the temperature adjustment factor. There's a different constant value that's used in the two standards. So we have an option to use the 6179 reference pi-t temperature pi factor instead of the Siemens temperature pi factor. So we've applied some changes to really better incorporate that 61709 standard if you want to follow it more closely than the Siemens standard. Okay. Moving on from the prediction standards, from the reliability prediction standards to the other modules, we've also added a few updates to the fault tree and the system safety assessment modules as well. So let me jump over into the fault tree, and this next update that I'll show probably falls into that category of why didn't we think of this earlier? Probably a good reason for that is, as Brett mentioned at the very beginning, most of the updates to the software are based off of user feedback and user requests. So if there's something you're not seeing in the software that you think would be a really good idea, please always bring it up to us. If you're wondering why is that not in the software, probably the answer is that nobody's asked for it yet. You could be the first and find one of your requests in the tool. And that's exactly what happened with this particular next request. So as you know, when you use libraries or appending, you can have data links created to a source file, and you actually don't even need to use the library feature to create a data link. Within the fault tree, and not only within the fault tree, but with any of the modules, you can data link an object to another object in that same file or in another file. David actually showed this in the FAMICA. He showed data linking a FAMICA failure mode to the fault tree for purposes of verification. We can also data link for purposes of taking the data. So in this particular project I have, my failure model, actually all of my failure models are data linked to another project. So if I click on this data link, we can see this failure model, this transformer failure model, is a data link to another project file, and that failure rate and the failure and repair rates are coming from this other failure model. We can use this for, again, standardizing failure rates. We can have a source library that everything is based upon. All my users draw their source data or their failure rates from that source file. And that way we can maintain data consistency. If we, the transfer data links option allows us to easily update data within this project file with changes that are made to my source project file. So this has been in the software for quite some time, using this data link facility for consistency of data, failure data throughout my projects, maintaining links back to a library and then updating with the latest data. Okay, that's been in the software for a while. So let me point out what we've changed with this latest version. And again, this is kind of a gee whiz, why didn't we think of this earlier? What was going on was the append feature was a feature that's often used to for multiple project collaboration. When you have multiple users working on the same project or on the same system, but they're building separate fault trees and you need to bring them all together at the same time at the end of the collaboration. Append is one of the preferred methods for that. So if I have another user who's building, say, the cooling system that is powered by that electrical fault tree system, I can use the append feature to bring those two fault trees together. Now, what was going on was those data links were getting stripped out during that append. I hit append and I'd lose those data links when I brought the data in via append. So the gee whiz, why didn't we think of that earlier, is now those data links are preserved. When I perform my batch append and link that electric system fault tree via the append, it's going to plug it right in. So it appended it and plugged it right in to these two gates here. So now I've built it out, and that's electric system fault tree we were looking at earlier is now plugged into this cooling system fault tree. these basic events now maintain their data links back all the way back to the source file. So that way I can still maintain my failure rate consistency. Even now we're now 2 steps removed from that source library file. I can still transfer my linked data to make sure this version of the file is up to date with the latest data from my original source library file. So rather than having to redo the append to get the latest failure data, I can get the latest failure data from here. Okay. What else do we have? Another major new feature in the fault tree has to do with verifications, aircraft verifications. There's a particular standard, I think it's a European aircraft standard, EASA CS25, and it has some specific requirements with regards primarily to latent faults. Specifically, it has to do with if you have a latent fault, the residual probability. Basically, since a latent fault is you don't, it's hard to know about it, right? You have to do some specific check or inspection to know about that latent fault. So we want to design the system robustly around them such that if this failure mode occurs that we don't know about, we want to be able to verify that even if it has occurred, our system's still safe. So the EASA standard has some requirements for what's called the residual failure probability. Basically, the residual probability that given, assuming that the latent fault has taken place, the remaining probability for the system to fail is tolerable. And so there's some requirements for that. And we've added some new features within the tool to do this residual probability analysis. So the way it works is if we have, so let's look at a simple fault tree. And again, this is very generic. I don't have any names or labels for anything here. But I have this particular fault tree. EV1 is a latent event, and it's coupled in cut sets with events EV2 and EV3. So if I look at the cut set analysis for this tree, it's quite simple, EV1 and EV2, or EV1 and EV3. Since EV1 is a latent fault, it's a dormant event, if it's failed, we may not know about it. So we want to make sure is that there's enough protection against that latent fault, that it's not, for instance, a very high failure probability if that latent fault has occurred. And that's where the residual probability analysis feature has been added. If we select this from the analysis menu, it's now added at the bottom of the analysis menu, we can examine any of our gates. So I have 4 gates within this project. I can choose one of them and do the residual probability analysis for the cut sets for this fault tree. So the residual probability analysis will identify groups of minimal cut sets that contain the same latent or active events and calculates the sum of the residual probabilities of those cut sets, assuming that the event has definitively taken place. So for example, event EV1 is our latent fault here. So it's showing this is the probability of that cut set. EV1 is our latent fault and it has a event probability. The residual Q here is the sum of the remaining events in the cut sets containing that EV1. So we know given that, or assuming that EV1 has failed, there's a residual probability of 2 times 10 to the negative 6 that the system fails, that the other events that share cut sets with event EV1 will also fail. So the EASA CS25 standard, in order to comply with it, requires that residual probability per flight hour is less than or equal to 1 times 10 to the negative 5th when considering a latent fault, meaning that if a latent fault has failed, there needs the residual probability of the remaining events in cut sets sharing that latent fault needs to be less than 1 times 10 to the negative 5th. So we're currently at 2e negative 6, so we're compliant with the residual probability criterion as defined in EASA CS25. Okay, so this, again, that feature makes it easier to identify those cut sets containing those latent faults and determine the residual probability of those latent faults. I go back there, let me look up that again. Of course, from here, we can not only see the results, but also export the results as well. They can be exported to an Excel file, and then it's saved in Excel. Speaking of compliance requirements and verifications, So aircraft requirements, not only aircraft, but also automotive is also done focusing around development assurance levels, DAL. And a couple of versions ago in the tool, we've added increased features relating to those development assurance levels. One of the things we've added is on each basic event. Actually, I think I have a separate file I'd like to show for this. Where is my other file? Oh, here we are. By the way, I have about 5 copies of Reliability Workbench open right now because I wanted to make sure I wasn't searching around for projects when I was trying to demonstrate them. So I pre-opened them all. So now I just have to find the correct instance of Reliability Workbench. So when we're doing a verification, we've had the DAL verification in Reliability Workbench for quite some time. And that allowed us to assign development assurance levels to the basic events. And then the system safety assessment module, we can do a DAL verification based on the probability or the requirements of a given failure in our hazard assessment, or system safety assessment, or FHA verification. So we've had the ability to assign these DALs for quite some time. One of the new features, and again, this might be one of those, say, why didn't we think of it earlier? One of those new features, now we can show that development assurance level. And it also, again, is not just aerospace development assurance levels, but also automotive ASIL levels can also be assigned to those events, and now can be displayed on the fault tree itself. I check that show DAL/ASIL. We'll get underneath the basic event, like you can show your failure rates, your beta factor assignment, the failure model assignment, the calculated event probability. There's lots of information you can show underneath the basic events. And now one of them is to also show those development assurance level assignments underneath those basic events. Okay, so now I can see that DAL A, DAL B, DAL C, etc. Or again, if I'm not using development assurance levels, if I'm using ASILs, I could show the QM level A, B, C, or D options as well underneath those basic events. This also ties in neatly to an expansion we've made to the safety assessment module with regards to those, that DAL verification. So when we implemented DAL verification into the software, when we implemented the DAL verification, we based it off of the ARP 40, I always get confused on the numbers, 4715, it's on here. 4754A actually is the standard that we're using for the DAL verifications. Basically the combinations of cut sets. What that does when you do that DAL verification, right here, it looks at the cut sets that contribute to the top gate, to the fault tree gate that's associated with the failure in the system safety assessment module. So this unenunciated loss of deceleration capability on an aircraft is associated with the fault tree gate, loss of all wheel braking. And we're using that for the probability requirements, but we can also, okay, and that probability is associated with an effect, the runway overrun, which then has a classification of catastrophic. And we can set a classification for that catastrophic, and then that will be used for the DAL verification, looking at the combinations of cut sets and the events that contribute to it. Now, previously, in the previous version, all that verification was done based off of ARP 4754A. In this latest version, we've added the AC23 for different aircraft classes. ARP 4754A is generally for, I think, for larger aircraft. Again, my aerospace clients will correct me if I'm wrong, but the AC23 is for different different aircraft classes or types. So anything ranging from small, single engine, up to through larger and intermediate and larger aircraft. And they have different verification requirements. So now when we're doing that DAL verification, we can say we're not doing it based on ARP 4754A. We're doing it, maybe it's an AC23 class 3 aircraft. And that essentially changes the rules for our DAL verification. When we look at the failures, the allowable classifications, cut set combinations. So it's showing all the cut sets, the component DALs, and then what classification is met based off of the standard right here at the very top that we're using. And of course, it's still, as before, it continues to highlight cut sets that don't meet our classification requirements. Okay. And so we have the requirements achieved, the what classification is met based off of the basic event development assurance levels. Of course, when we save the results, this header is also saved into our export CSV file. So it will tell us what classification criteria we use when performing this DAL verification. Okay. And one final thing that we've added in the safety assessment module is these environment categories. We've added additional environment categories. Of course, as before, you can adjust the names of those environment categories. So in aerospace, we might be using things related to the weather. In automotive, if we're doing automotive and we want to track the environments, we might be doing things related to the driving conditions, such as the surface conditions, the traffic, the vehicle configuration, various things like that. Now, of course, the way these environments are used is still somewhat the same, although the user interface looks a little bit different. We'll come down to the environments. We'll see all those different environment categories with a checkbox next to them. And so we can check which environments this particular failure mode applies to. So we may have failure modes that only occur in wet or icy conditions, for instance, and don't occur in hot or dry or conditions. So we can choose those environmental conditions. That works as before, but that interface works a little bit differently. We have more environmental categories that we can choose. We can collapse environmental categories that don't apply and check the environments that do apply. So we've expanded upon that from the previous version to allow us to track those different environment conditions perhaps more efficiently. We're coming to the end of our time, so I have just one last feature that applies across all the modules, the various different notes fields, and I think David hinted at this in the FAMICA module, but it applies to all of the modules. The notes fields that you've probably used. Remember, every single object basically in Reliability Workbench has these notes fields. In the fault tree, we have 8 customizable notes fields for all the basic events, all the gates, all the failure models. All our failure models have these 8 customizable notes fields. The length of all these notes fields has been increased from 2,000 characters to 40,000 characters. So you can now write a small novel in the notes fields of your basic events, for instance. It just basically allows you to track more information related to each item. And of course, those notes fields can be displayed in reports. And so it allows you to be more precise and record more information relating to all the different objects within your system. Okay, I think that's taking us close to the end of our time. Brett, did you have anything that we wanted to cover last? Any questions that you wanted to answer?
No, I really appreciate your time as well as David's time. And, as you had mentioned, this is just a small handful of the updates and upgrades that we've implemented. But for time's sake, we wanted to cover some of those key highlights. We've also recorded this presentation, and that will be sent out to the attendees so that you can reference that, or if a colleague wasn't able to join, you'll receive that here in a little bit. And also, if you have any questions regarding the software modules that were covered today, please don't hesitate to, reach out. Here's the contact information. Sorry, right here. Feel free to reach out at any time and be happy to help you out. Let me switch to my screen there. And once again, thanks for your time. Have a fantastic almost weekend, one more day to go. And make sure that you utilize David as well as Joe as a resource going forward. Once again, appreciate your business and partnerships, and have a fantastic day. Thanks, everyone.
Take care. Goodbye.
Bye now.